Okay, a new definition for you. It's the adjugate of a, the adjugate. This seems a bit random, I'd imagine, but it is going somewhere. It's going to, this adjugate is, it's going to give us a new formula for the inverse. It'll be A inverse will be 1 over determinant of A times the adjugate of A. So it gives us a new, don't write this down yet, I just want to motivate what we're doing now. So adjugate will have its uses. Okay, so it's composed of what's called the cofactor matrix, but then we transpose it. Now recall the ij cofactor is Cij, which is -1 to the I plus j, times the determinant of the ij minor here. Now this guy gives you that plus minus plus thingy. And this is a determinant of some smaller matrix. Okay, so we will see how this works shortly. But I do want to say that in English, we say that the adjugate, that's an A. Oh my gosh, that's an A right there. The adjugate of A is the transpose of the cofactor matrix. Having trouble making my A's today. Factor matrix. So that's what this equation is saying up here. This guy. Okay. Do some examples to illuminate this, especially this weird thing. So an example. I'll find the adjugate of this matrix. So my formula is adjugate. Let's go green here. I said let's go green here. Thank you. Adjugate of A is the transpose of the cofactor matrix. So I'm going to find these cofactors. There's going to be 9 of them, 1 for each entry here. So why don't I go ahead and just start calculating those. So C11. So remind you the formula is Cij is -1 to the I plus j times determinant of Aij. So C11 would be -1 to the 1 plus 1. And then it's the determinant of this Aij thing. Now the Aij thing is I take, well in this case it's going to be A11. So what I do is I take the 1 and the 1. So I smush the first row, smush the first column, and I take what's left. So that's my Aij there. So we can see we got a row of zeros here, so we can see this guy's going to be 0. C12 would be -1 to the 1 plus 2 times the determinant of, okay, first row, second column. So I smush first row, smush the second column, and what's left? 3, 0, -1, 1. So this determinant ends up being -1 times 3, -3. Okay, so I continue in this way, and I calculate everything. With practice, you can do this in your head. So the C13, okay, just in my head, I'm smushing this, doing this determinant, I'm just remembering that it's going to be plus or minus 1 in front. So C13, I got a 3 for the determinant, and it's going to be plus 1. So it's going to be plus 1, and then times 3 for the determinant. Okay, so I continue in this way. And I find all the cofactors. And then I have to remember to transpose at the end. So C21 is negative of some determinant, so it'll be 1. So I'm doing this mostly in my head. C22 would be negative 1. C23 is negative 2, but becomes plus 2 because there's a negative. C31 is 0. C32 is, let's see, I got a plus 3, but becomes a minus 3. So I've been doing this for a couple decades now, so I can do this in my head, but you will too with practice. So we get plus 6 for the last one. So I got these numbers here. So the adjugate of A is, again, the cofactor matrix transposed. So I take all these numbers, 0, then minus 3, and then 3. Okay, so I took these numbers first, and 1, negative 1, 2, 0, minus 3, 6, and then I transpose. I may have a mistake here, but I'll fix it up later if I do. So you take the cofactors, you put them into a matrix, and then don't forget to transpose, because that will be what is a common mistake, forgetting to transpose. Okay, let's take a peek at the answer here. I got it up at the top right here. See if I got it right. Holy guacamole, I did not make a mistake. Good job. Okay. I want you to try one. Try this one. Oops. Here's the answer there. Here's the answer over here. Give this one a whirl. If you're having trouble, let me know.